This is the Satellite Foundation course for GOES-R training on the legacy atmospheric profiles. These satellite retrievals use GOES-R ABI data in lieu of sounder data. I'm Scott Lindstrom and I'll be guiding you through the training. At the end of this training, you should be able to describe the differences between legacy atmospheric profiles and GOES sounder profiles, understand how and why legacy atmospheric profiles are created, and be familiar with some of the uses of the products. LAP products are boxed in yellow. They originate from atmospheric profiles of temperature and moisture and include stability indices such as lifted index and convective available potential energy. They also include total precipitable water. GOES-R ABI channels have considerable spectral overlap with GOES 14 and 15 sounder data, so ABI information can be used in lieu of the sounder, which is necessary because there is no sounder on GOES-R. ABI also has better spatial resolution than the GOES sounder, 2 kilometers on GOES-R ABI versus 10 kilometers on the GOES sounder. ABI scans the full disk much more quickly than the GOES sounder, which scans only part of CONUS every hour. LAP products are created every 15 minutes in the full disk domain, every 5 minutes in the CONUS domain, and every minute in the mesoscale domains. This image compares the near global coverage for ABI LAP products to the current GOES sounder. LAP products give far better spatial coverage more frequently than the GOES sounder. This slide depicts the channels present on the GOES-R ABI, on the present GOES sounder, and on the present GOES imager. The present GOES sounder does a better job of sensing temperature because of the abundance of CO2 channels around 4 to 4.5 microns and around 14.4 microns. ABI and GOES sounder do have similar moisture sensing channels, as shown here, so moisture retrievals from ABI and the GOES sounder are similar. ABI channels are spectrally broad compared to the more narrow GOES sounder spectrum. Thus, ABI retrievals will smooth over features that have small vertical scales. The GOES sounder, with its more spectrally narrow windows, is better able to resolve small-scale features. There are 2 channels on ABI that aren't on the GOES sounder. 8.4, which is in a region where SO2 absorption can be important, and 10.3 microns, the clean window channel. This shows the spectral response function for the GOES 15 sounder channels on top of the brightness temperature spectrum drawn in red. Note the abundance of channels around 14.4 micrometers and around 4.4 micrometers. The ABI does not have those CO2 channels. It does have fairly broad channels in the water vapor absorption region, however, so that moisture can be sensed with about the same abilities as the GOES sounder. This slide summarizes the previous slides. ABI and GOES sounder have similar water vapor channels, but ABI has fewer temperature sounding channels. To increase the number of levels of information, ABI data are used in concert with model simulations. If you don't do that, how many layers of information do you have when you only use ABI? Not many. But by using forecast information in GOES-R ABI data, you get information comparable to that from the forecast plus the GOES sounder, about 5 layers of moisture, and more layers of temperature, but temperature information from the ABI is not as good as it is from the sounder. Legacy atmospheric profiles are created with an ABI footprint of 5 by 5 pixels, so there are 25 ABI pixels in each LAP footprint. LAP products therefore have spatial resolutions that are similar to the present GOES sounder. Values are created for every full disk scan, for every CONUS scan, and for every mesoscan. The background fields used in creating legacy atmospheric profiles are from the GFS forecast. The accuracy of the products is noted at the bottom. As with GOES sounder DPI products, LAP products are clear sky only, but an all-sky product that is valid in clear and cloudy regions has been developed. The first step to produce the profiles is a regression that uses coefficients that were trained to give the best statistical relationship between observed temperature, moisture, surface temperature, emissivity, and ozone. First guess data are GFS. Then the retrieval uses a radiative transfer model. Differences between the regression values and the radiative transfer model values are minimized during the retrieval step. Further technical details are available in the Advanced Theoretical Basis document linked at the end of this training. Clear Sky Legacy Atmospheric Profile products are only produced when at least 20 of the 25 fields of regard in the 5x5 pixel set have clear fields of view. Other specs on lap generation are listed on this slide. Weighting functions for the GOES-R ABI shown at the bottom show few peaks above the surface. Lap profiles therefore struggle to improve on the GFS representation of temperature. There is mid-tropospheric moisture information in the ABI in the form of 3 water vapor channels, however. Thus there is improvement in the moisture field, as we'll see shortly. This figure shows an error analysis for Clear Sky results comparing radiosondes on the bottom and ARM-CART rayobs on the top, and GFS and lap vertical profiles. Temperatures on the left, moistures on the right. These are Clear Sky only results. Bias improvement is largest for moisture in the mid to upper troposphere. That's where satellite observations give the most added information. Reduction in the bias values is pretty small for temperatures. Where the observations are giving information is described by the weighting function. This shows weighting functions for the US standard atmosphere. There are websites that show real-time weighting functions based on current radiosondes that you can find online. Weighting functions describe from where in the atmosphere information is being detected by the satellite. Most of the information from the ABI water vapor channels is coming from a region between 300 and 700 millibars. The level will be higher in a moist atmosphere and lower in a dry atmosphere. That's why the bias correction you saw on the last page is largest in the mid and upper troposphere. Weighting functions for most of the other ABI channels peak near the surface. They're window channels. There's not a lot of mid-tropospheric temperature information available from ABI channels because CO2 channels around 4.4 micrometers and at greater than 13.3 micrometers are not present, as they were present on the GOES sounder. Baseline products are Clear Sky only and should look familiar to forecasters who have used GOES sounder DPI products. Examples of CAPE and total precipitable water are shown here. The dark blue region is where the clear retrievals have good data. Yellow and cyan regions will not have data in the baseline products. A big display difference in AWIPS, however, for GOES-R Clear Sky products is that Clear Sky products will show no data where clouds are present, unlike the images on this page that blend cloud temperature information with a Clear Sky product. All Skylab products have been demonstrated at the Hazardous Weather Testbed starting in 2014, and forecasters there found great utility in gradients and time tendencies because convection frequently formed along gradients in the fields. Here's an example with modest convection in a region that is a diagnosed minimum of CAPE, moving toward higher values of CAPE. What would you expect as the convection moves from a local minimum in CAPE toward the larger value? 1 hour later, the convection had intensified. This shows DPI CAPE from AWIPS. This is a Clear Sky product that is baseline, not the All Sky product that was available at HWT. Nevertheless, there is information, in particular here over the Dakotas. Note how the CAPE values on the surface dew points align. A nose of higher CAPE overlaps with a slight risk. Vertical lap profiles can also be loaded, allowing you to monitor the destabilization of the atmosphere. Again, most of the information added from ABI for these kind of profiles is in mid-level moisture. This particular set of images is for a region over southeastern Wisconsin. The destabilization viewed in the profiles, the cursor points to the sounding location, accompanied the development of showers. Lap total precipitable water shows tongues of moisture that can be useful in assessing the threat of heavy rain. Full disk imagery can show atmospheric rivers, for example. This is a Clear Sky only product, however. You can also find these data online at the website shown. Clear Sky baseline products are available there. But so are All Sky products. The background field from the GFS is used where the clear or cloudy retrieval fails. Otherwise, you are getting data that are influenced by the GOES-R ABI observations. You can compare the lap total precipitable water to other global total precipitable water estimates, such as from MIMIC. They show comparable values. Supplemental information is listed here. Read all about it. This concludes the Satellite Foundational course for GOES-R on Legacy Atmospheric Profiles. Summary points are listed on this slide. Thank you for listening.